Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go. My dear friends, the agenda behind today's lecture is to take around 5 to 6 number of problems, and those problems were picked up from the GATE year of 2021 from the topic called calculus. Probably 2 questions I would be picking from vector calculus, and approximately 3 number of problems would be picked up from the numerical method. Anyways, the student who have been watching my video first time, let me explain about the series which we have been running over the engineering mathematics. So over this series, what we are going to do, we are taking the reference of the questions from the engineering mathematics which have appeared in year of 2021, and taking the reference of those questions, we are building the concept for the year of 2022. So till this point, probably each and everything must be clear to all of us. Agreed? So may I know the quality of video as well as audio? If it is perfect, just write perfect over the live chat. So at least I'll have the fair idea. Each and everything is okay now? Okay then, keep aside each and everything. Let me go back. The first question which I would be taking in today's class, that comes from the page number 16. Just a minute. Yes, that comes from the page number 16. The problem have appeared in civil engineering year of 2021, and yes, they had the 2 number of sessions. So this problem is coming from the forenoon session. Let's see what the problem exactly it states. The value of the integration from 0 to 1 e to the power of x dx using the trapezoidal rule with the 4 equal sub interval is. The 4 different options were attached along with this problem. Option A was 2.192, option B was 2.718, option C was 1.727, option D was 1.718. You had to get the precise most answer for this given problem. Anyways, before going into the detailed analysis of this problem, you should have a little bit idea about the trapezoidal rule. May I know what the trapezoidal rule does? It converts the complete area under the curve into a small segment of the trapezoids. Like, we had to get the integration of e to the power of x from x is equals to 0 to 1. That means we had to calculate the area under the curve which was occupied by the e to the power of x from x is equals to 0 to x is equals to 1. So what I would be doing at very beginning, let me take a xy plane. Here goes the y-axis, here comes the x-axis. Here it is x-axis, here it is y-axis. Yes, and how the e to the power of x looks like? Sir, where will be getting the book, sir? Anyways, and how the e to the power of x would look like? E to the power of x would be exponent increasing function which would start from 1, taking the reference of y-axis, and it would be keep increasing. And you had to find the integration from 0 to 1 of e to the power of x dx. That means you had to find the area under the curve which has been bounded by x is equals to 0. What does that mean of it? That means it is nothing but y-axis. Similarly, x is equals to of 1. Obviously, it would be a vertical line which would be shifted by x is equals to 1. It is x is equals to 1. It is x is equals to 0. Next is x-axis itself, and the next is the function e to the power of x. Agreed what I am saying? That means you had to find the area which has been occupied under this curve, this one. I have seen many of the students do blunder. What they would do, you know? Simply they would calculate this integration using the manual method, my dear friends. That is an analytic method. And once you calculate the area under the curve of e to the power of x from x is equals to 0 to 1, the answer what you are getting, no, that would be the accurate most answer. But they do not want the accurate most answer. They want the answer after the approximation using the trapezium rule. What I am saying, nobody should calculate this value using the analytic method where the integration of e to the power of x would be e to the power of x. Now they can feed x as 1, so it would become e to the power of 1 minus of 0, which would become e minus of 1. Nobody should do that. Otherwise, you would be getting a wrong answer. They have been specifically specified that you had to use the trapezoidal rule, and how many number of steps of the subinterval has to be used, it has also been clearly given. See, in trapezoidal rule, what we do? In trapezoidal rule, the complete span of x is subdivided into the small part of trapezium. May I know what does it mean by the trapezium? Trapezium is a type of quadrilateral whose one pair of arms are parallel. One pair of arms are parallel. You yourself would be able to understand this arm are parallel to each other. Yes, and if we have both of the pairs as parallel, definitely it would become a parallelogram. So it is not a parallelogram, it is a quadrilateral where only one pair of the sides used to be parallel to each other. May I know what used to be the area under the trapezium? The area under the trapezium used to be half times of the distance between the two parallel side. Let's take, for the time being, it's been taken as h, and similarly the addition between the two parallel side, let's take this side has been taken as a and this side has been taken as b. Probably this thing you have studied in class 8th as well as 9th as well as 10th. So I do not find that you will not be able to recall that the area occupied by the trapezium used to be defined as a half times of h into a into b. Yes, now at least in this problem we had to occupy this complete area into the 4 different equal subinterval. That means you can say it would be my first interval, it would be my second interval, and it would be my third interval. Yes, it would be my third interval. So till this point, each and everything must be clear to all of us. And now we had to draw the trapezium over here. How the trapezium would look like? Here, similarly here, similarly here, and similarly here, similarly here. Anyways, before getting the exact most answer, I would like to ask from each one of you, if you will calculate this area under the curve using analytic method, and if you will calculate this area under the curve using the trapezium method, where you will be getting higher value, I repeat, you had to get the integration of e to the power of x from 0 to 1. If you use the analytic method, through the analytic method, the integration of e to the power of x would be e to the power of x itself. If you will take its upper limit, it would become e to the power of 1 minus of e to the power of 0, which is precisely equals to of e minus 1. If you exactly wants to know how much answer we are getting for this, so here it's gonna be, just a minute, e minus of 1, which is 1.71, 1.718. Yes. Tell me, after using the trapezium rule, the value which you will be getting, which is nothing but the area under the curve, which would be greater than 1.718, or would it be lesser than 1.718? My dear friends, try to understand what I am saying. It has been upper facing concave. This e to the power of x from x is equals to 0 till x is equals to 1 has been upper facing concave, and hence if you will draw the trapezium taking the reference of their edges, always the area which was calculated by the trapezium would be greater than the actual area occupied by the e to the power of x. Could you understand what I am saying? You can see by yourself. If curve is upper facing and if you have taken the reference of these two tips, and if this two tips has been joined, and if you have made a trapezium, definitely the area which was occupied by the trapezium is more than the area which is supposed to be occupied by the upper facing concave. So till this point, probably each and everything must be clear to all of us. So what are the values can be ruled out? Definitely 1.718, it has been an analytic value, and many of the students who are smart enough would simply be calculating using the analytic method, and they will be getting the answer as 1.718, which is a utterly wrong answer. That's the first thing. Nobody should be smart enough like straight away they are calculating the value using a calculator. No, that should not be taking place. So the area has to be larger. So the possible answers could have been A, could have been B, could have been C. Yes, because all of three numbers are greater than the 1.718. Till this point, probably each and everything must be clear to all of us. See how we calculate the area under the curve using the trapezium rule. My dear friends, as we were interested finding this complete area, why don't we calculate the area occupied by the each and individual trapezium, and end of the day we'll add them together. Just focus over the area under this trapezium. So I have taken this first vertical axis as x0, yes, x0, and here at this point the worth of the function has been taken as what? Y0, or simply this point can be taken as x naught the worth of abscissa, y naught the worth of ordinate. Similarly, here goes x1 y1, x1 y1, here goes x2 y2, here goes x3 y3, so on and so forth. Here goes x4 y4, here goes x3 y3. And as their intervals have been uniform, that means the complete span of 1 has to be subdivided into the 4 equal parts. So here goes 1 minus of 0. 1 was the upper limit, 0 was the lower limit. It has to be subdivided into the 4 equal parts of intervals. So simply it becomes 0.25. That means the vertical distance between these two parallel lines always would be 0.25. Would always be 0.25. Till this point, probably each and everything must be clear to all of us. So let me focus over the area of the first trapezium. The area of the first trapezium. Tell me what would be the area of the first trapezium? Half. That is vertical distance between the two parallel sides into the addition of the heights or the side length of two parallel sides. Here the side length is nothing but the y0, and similarly here the side height is nothing but y1. So here it's gonna be y0 plus of y1. Yes. Similarly, you will be calculating for T2. Similarly, you will be calculating for T3. Similarly, you will be calculating for T4. And end of the day, the formula what we get now, once we'll add them all of the areas together, you will get to know y0 have only appeared once with the first step. Similarly, y1 has been appeared twice with the first strip as well as second strip. Similarly, y2 has been appeared twice, y3 has been appeared twice, and similarly y4 has appeared only once. So once we'll add all of the areas occupied by the first, second and third strip, end of the day the result what we get, it's simply gonna be half times of h, the first and last magnitude, which is y0 plus of y4, plus of, you will be having the repetition of the magnitude in between, which is falling from last to first. Agreed, no? So many of the times I have seen the students straight away by heart this formula, but exactly they do not know from where the formula have come out. So the formula have come out while adding the area under the curve of each and individual stripes, and the stripes has been taken as a trapezium. That means the area has been encountered as the area which would be occupied by the trapezium itself. So here half times of h, y0 plus of y1. Next it would be half times of h within the bracket y1 plus of y2, y2 plus of y3. So the y1 has been repeated twice, y2 would be repeated twice, y3 would be repeated twice, only and only y4 would not be repeated twice, and y0 would not be repeated twice. That is why it is not getting multiplied with 2 and it's getting multiplied with 2. Yes. So end of the day, you have to make a table. What I am saying, end of the day, you have to make a table. You have to calculate the value of f of x at x is equals to 0, where the x is equals to 0 is simply equals to 0. May I know what would be the value of function f of x at x is equals to 0, which would be simply equals to of e to the power of 0, which is nothing but 1. Similarly, at x is equals to 1, you will be having magnitude as e to the power of 0.25. Similarly, here it would be 0.5, 0.75, and end of the day, you will be having e to the power of 1. Yes. Agreed, no? Agreed? Thanks, dear Manik Singh. Your way of teaching is awesome. Thank you, dear. So could you understand what I am saying? So that is what I used to say, my dear friends. See, explaining each and everything with the help of question is not that simplified way. That is why I used to take the theoretical portion separate as well as numerical portion separate. But still with the help of question, if we are able to learn few of the new concept, we should learn it. And I know many of the students just by heart it. So rather by hearting, you could have figured it out one thing, what it is. At the outside, the half would get multiplied with the h, where the h is nothing but the interval size or the step size. Towards the inside, the first and the last data of y would come. Here, like we had the 4 number of subinterval, so obviously the first data would be y0 and the last data would be y4. If this problem could have been separated, or if this problem could have been segregated into the 5 or 6 or 7 number of subinterval, in that case it would have been y7, and the remaining term would come along with 2, that would be y1, y2, y3, y4, y5, y6. Could you understand? Could you understand? So end of the day, what I am saying, already I have solved this problem out. So the formula which we have used for the calculation of the area under the curve using the trapezium method was h2 divided within the bracket y0 plus of yn plus of 2 times of y1 plus of y2 plus of y3 dash 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 y of n minus 1. At least in this problem, how many number of y's we have? We have y0, y1, y2, y3, y4. So obviously here it would come y0 and here it would come y4 and here it would be 2 times of y1 plus of y2 plus of y3, which we have just derived here. And similarly, at the same time, we also must be having a bit idea about the step size, my dear friends. It has been clearly told you had to start from the first lower limit and you had to go till the highest side, which is nothing but the upper limit, and it has to get subdivided into the 4 equal parts. So here goes the upper limit minus of lower limit divided by the number of sub intervals, which is nothing but 4. So you got to know that each and individual sub intervals or step size would be in the width of 1 by 4, which is nothing but 0.25. So the question have started from here. See what is happening over here. At very beginning, I have taken x0 is equals to 0, then we took x1 is equals to 1 by 4, then we took x2 is equals to 1 upon 2, x3 is equals to 3 upon 4, and end of the day x4 is equals to 1. Correspondingly, we calculated the value of y0, y1, y2, y3, y4. The value of y was known, which was precisely e to the power of x. That means simply x has to be fed in over the e to the power of x, so just to get the values of y. So here it becomes e to the power of 0, which is simply 1. Here it becomes e to the power of 1 upon 4, e to the power of 1 upon 2, so on and so forth. End of the day, you got all of the corresponding value. May I know what it is? It's the value of y0, it's the value of y1, it's the value of y2, it's the value of y3, it's the value of y4, it's the value of y4. Yes, you just had to plug this data over the standard formula of the trapezium method, you'll get the answer. Yes, we have started feeding the data. Y0 would be 1, similarly y4 would be e to the power of 1, similarly 2 times of remaining data which are coming in between to the last and the first component, which is e to the power of 1 upon 4 plus e to the power of 1 upon 2 plus of e to the power of 3 upon 4. The data which we are getting at last is simply going to be 1 upon 1.727. Even I would say one thing. If you really wants to recall or if you really wants to by heart the formula which we use in case of trapezium method, I would say just by heart h by 2 towards the inside. The first data and second data would be bare, and similarly the remaining data which is coming in between the first and last data would get multiplied with 2. So till this point, probably each and everything must be clear. The answer which we are getting is simply going to be 1.727. I know many of the students would have got or would have calculated answer as 1.718, which was a wrong answer. The best most answer which we get is going to be 1.727. So till this point, probably each and everything must be clear to all of us. In the same sequence, let me go into the next question, which comes from the page number 18. Just a minute. Which comes from the page number 18. Yeah, one of the very well designed problem have appeared from the concept of probability density. Let me see what the problem states. The shape of cumulative distribution function of Gaussian distribution is. The 4 different options were attached along with this problem. The first option was a horizontal line. The B was a bell-shaped, the C was a straight line at 45-degree angle, D is S-shaped. Tell me what would be the best most answer for this given problem. I know many of these students bluntly mark the answer as bell-shaped because they used to by heart what Gaussian distribution is also called normal distribution, and it's also called bell distribution. So as they used to by heart, so without spending even fraction amount of time, they would simply have marked the answer as a bell-shaped, which was a wrong answer. My dear friends, you had to look into each and individual words of this problem, then only you would be able to go into the final conclusion. What it says, the same of cumulative distribution. It is not talking about the probability density function, it is been talking about cumulative distribution. How the cumulative distribution is to be calculated? My dear friends, if you have a probability density function which has been defined as f of x, it has been a probability density function for a given continuous random variable x, then capital F of x is being defined as integration of f of x. It starts from minus infinity till x dx. Till x dx. May I know what does it actually mean of? That means at any moment of x or at any point of x, the cumulative function or probability cumulative function would be same as the area under the curve of PDF, which has been started accumulating from minus infinity to till that point x itself. Till that point x itself. Could you understand what I am saying? Could you understand what exactly wanted to say over here, my dear friends? Nobody should get confused if in this problem, if they would have been discussed about PDF, definitely answer would have been a bell-shaped. But rather talking about the bells, what PDF they have been discussing about the cumulative distribution and how the cumulative distribution or cumulative function has been defined. The cumulative function has been defined as the area under the curve of a small f of x dx till minus infinity to the point of interest, and the point of interest has been x. The point of interest has been x. Anyways, once again, come back. How the normal distribution looks like. How the normal distribution looks like. Let's take, it has been x-axis and it has been y-axis, where I am going to draw the probability density function PDF, which is a function of x. Once you'll recall how the PDF looks like. The PDF used to have its highest magnitude as 1 upon root over 2 pi sigma square when it takes place, when you will be having e to the power of 0, when the e to the power of 0 takes place, when the value of x is precisely equals to of mu, where the mu is nothing but the mean of the random variable capital X. And what is the sigma over here? The sigma is the standard deviation of the continuous random variable small x. So this thing must be clear to all of us. It is the standard deviation of your continuous random variable small x, and similarly mu has been the mean of your continuous random variable small x, mean of the continuous random variable small x. And you yourself would be able to understand this curve f of x has been a even function taking the reference of x is equals to mu. Why? If you feed x is equals to mu, it becomes e to the power of 0, 1 divided by root over 2 pi sigma square. And now if you go x is equals to, let's take mu towards right side, towards minus side, towards right side, towards minus side. What is happening over here? You can see very well the magnitude is fetching the same value. Magnitude is fetching the same value. So till this point probably each and everything must be clear to all of us. If you don't understand, you can take the scenario like x minus mu is 2 somewhere. Mu is 2 somewhere. If you take x is equals to, let's take 3. Either you take x is equals to of 1. In both of the cases, 3 minus of 2 would become 1. Even 1 minus 2 would become minus 1. But this square would make it again plus. So what is happening over here? So if you talk about the probability density function, obviously it used to be a bell-shaped and used to be symmetric around x is equals to of mu axis. X is equals to of mu axis. Till this point probably each and everything must be clear to all of us. And as the complete area occupied by the PDF used to be 1, and as it has been symmetric around x is equals to mu, that means the half of the area would be covered towards the negative value of x or towards the lesser value of mu, and similarly half of the area would be covered towards the higher value of mu. So till this point each and everything is most clear. And now we have been talking about cumulative probability function, which is f of x, and how it's been defined. It has been defined as an area under the curve which is starting from the negative most value of x, which is minus infinity, till that point. That means at this point, if you are interested finding the capital F of x, you had to integrate all of the area which was occupied from minus infinity till this point. Similarly, if you had to calculate the worth of capital F of x, what would be the worth of capital F of x? It would be the area under the curve of this small f of x. It starts from x is equals to minus infinity till this point. One of the most interesting thing. the small f of x is positive, and yes, for all of the PDFs, the small f of x used to be positive. Small f of x used to be positive. So if you have start taking a higher value of x, what is happening? The area which is getting occupied during integration is keep increasing. What I am saying, if you take the area under this curve, definitely it would be smaller. If you will take the area under x is equals to minus infinity till this curve, definitely it would be larger. Even it would be larger, even it would be larger. So how would be the curve towards output side? It would be keep increasing. It would be keep increasing. And how the curve would be? Obviously curve would be sort of this. Curve would be sort of this. And once it reaches towards plus infinity, it will try to get saturated at magnitude of 1, because the area under the curve of f of x dx for throughout the range of x used to be 1. And yes, if you have reached to the x is equals to infinity, the area have reached from minus infinity to plus infinity, the area under the curve has to be precisely 1. Area under the curve has to be precisely 1. Could you understand what I am saying? So may I know what would be the best most answer? The best most answer is gonna be S saved. S saved. S saved. See what is happening? At very beginning we had a lesser area, and now if we are increasing the value of x, we had a higher area. And now this area and this area, would it be increasing or would it be additive? Would it be subtractive, my dear friends? If the complete area has been made towards upside, their areas would be additive. If this area would have been made towards downside, this area and this area would have been subtractive. But as far as the small f of x is concerned, as far as the PDF of the Gaussian distribution is concerned, this complete PDF has been made towards the positive value of y. That means they would always be additive. And once they are always additive, yes, once they are always additive, what is happening over here, my dear friends? They are getting added together. And once they are getting added together again and again and again, or I would say monotonically, capital F of x would be increasing. Capital F of x would be increasing. So may I know what would be the best most answer? I know many of the students would have stuck over this problem. Many of the students would have marked the answer as B. Probably this was the problem for 1 mark, no? So many of the students will think, sir, the problem was having the weightage of 1 mark. So straight away they have asked one question. My dear friends, it was not a straight question. Until and unless you do not have a fair idea about the cumulative function, you would do mistake over here. And I mistakenly believe saved. Yes? Yes, no? Could you understand what was the basic crux behind this problem? Yes, probably each and everyone must be able to digest what exactly I wanted to say. Exactly I wanted to say. Yes, that is why I have even solved this problem completely. See, at very beginning, I took the reference of the standard PDF which is getting followed by normal Gaussian distribution, which is 1 upon root over of 2 pi sigma square exponent which was raised to minus x minus mu divided by of root over 2 sigma to the power of 2. Yes, it would be a Bale-shaped, but it has been a PDF. It is not the cumulative function. What would be its maximum value? The maximum value would be appeared at x is equals to mu. At x is equals to mu, the power becomes 0. E to the power of 0 would be 1. So the maximum magnitude would be 1 upon root over 2 pi sigma square precisely at x is equals to mu. And now what I would be doing? Now I would be applying the standard formula which we use in case of cumulative function. That is nothing but the integration from minus infinity to x, small f of x, and yes, it has start getting accumulated. And one of the more important thing, at x is equals to mu, it is not 0. At x is equals to mu, the magnitude would be precisely 0.5. Why? Because the PDF has been the symmetrical PDF at x is equals to mu. So the area which was occupied in this region was 0.5, and as you keep adding the area from minus infinity till x is equals to mu, you have added your area exactly as 0.5. So obviously here the magnitude has to be 0.5, and as the value of x is keep going and as it is reaching towards infinity, it will try to get settled down at 1. It will try to get settled down at 1. Yes. So here goes 0.5, here goes 1, and the shape of the structure is type of S-shaped. S-shaped. Yes. Many of the students did mistake over this problem. Anyways, let me move into the next question, which would be the 19th question, which would be the question from the page number 19. 19. Yes, it has been done. So. Let me take the next question from page number 20. Yes. Yes, this is the 20th question. This is the 20th question. See what this problem exactly indicates. The value of abscissa x and the ordinate y of a curve are as follows, my dear friends. See, whenever they design the problem related to the numerical integration, what I am saying, whenever they design the problem related to the numerical integration, either the function f of x is clearly given in your problem, otherwise they would be giving a table where the value of x and y would be related to each other, taking the reference of that function. Anyways, you need not to go back to that function just by taking the reference of this table, where one side you would be having the values of abscissa, towards another side you would be having the values of ordinate. End of the day, you can calculate the area under the curve. Anyways, I did not see what was the question. The question was based on which particular concept, but by watching this table itself, I could have figured it out. Yes, this problem would be related to the numerical integration. Let me see whether it was same or not. Yes. By Simpson's 1/3 rule, the area under the curve rounded to the 2 decimal place is. My dear friends, the first question which I have taken in today's class was the area under the curve, or the calculation of the integration using the trapezium method. But in this question, we had to smash this problem out using the Simpson's 1/3 rule. May I know what's the basic difference between trapezium method or Simpson's 1/3 method? My dear friends, in case of trapezium method, as the name itself is self-explanatory, I was bifurcating the complete area under the curve into the small parts of the trapeziums. Yes, trapeziums. How did we do that? See, we had the two vertical parallel line and their edges were connected. Using a straight line. Which type of structure it became? My dear friends, towards the bottom side, obviously it has been a flat because we are taking the reference of x-axis. Similarly, towards the left hand side, towards right hand side, it has been a parallel to each other, and towards the upside, it is making a certain straight line. So it has been a trapezium. So in case of trapezium method, we used to take linear approximation between the 2 points over the function. Yes, 2 points over the function. But in case of Simpson's 1/3 rule, I use second degree polynomial for the better approximation. What I say, I use the second degree approximation for between these 2 points. So if you want, I can mark it over here. In case of Simpson's 1/3 rule, I use second degree polynomial for the approximation. Anyways, I would not go into the detailed derivation part of the Simpson's 1/3 rule, but still, with the help of 2 or 3 important number of steps, I would able to explain how the Simpson's 1/3 rule must be working. My dear friends, see what is happening over here. Let's take, you have to find the area under these 2 points. Let's take the first point has been x0. In corresponding to x0, you had the worth of the function as y0, and similarly, let's take, this is what your x1 is, and is in corresponding to the x1, you have got the worth of the function as y1. But as it has been clearly given, what I am saying, you cannot approximate linearly between these 2 points, x0, y0 and x1, y1. You had to take a second degree polynomial. May I know what does it mean by the second degree polynomial? The second degree polynomial is a structure of parabola. Agreed what I am saying? Yes, you can see, no? Like y is equals to of x square, it is upper facing parabola. If you take y is equals to x square plus of 1, again it's gonna be upper facing parabola, just got shifted by x is equals to 1, y is equals to 1. Even you take y is equals to of minus x square plus of 1, still it is a lower facing parabola. So what I am saying, whenever you are approximating the integration using the Simpson's 1/3 rule, you are going to approximate the curve between the 2 tips of the function using the second degree polynomial. And whenever you have the second degree polynomial, by default you are going to approximate the structure which is very same as parabola, But here one problem do come. May I know what? If you approximate parabola between these 2 points, you want even one more point in between. You want one more point in between. If you're writing x0, y0, it's as x1, y1, you must be knowing at least one more point in between. For the time being, you can write this as a x2, y2. This as a x2, y2. Just try to understand what I'm saying. If the worth of this function or the worth of the function at this point has been lower than this and this, the type of parabola which would be approximated would be upper facing. Similarly, if you have gone through another situation where the worth of the function at x2 has been greater than the value at x0 and x1, obviously you would be approximating with the help of lower parabola. Could you understand what I'm saying? Lower parabola. Now one thing is happening over here. How many number of intervals logically you have taken? Although I have just taken one interval, but now that one interval has been subdivided into the two parts, that means you had the two number of intervals. Could you understand what I'm saying? So in general, few of the important point you must remember whenever you are dealing the problem with the Simpson's 1/3 rule. The first important fact, the degree of polynomial which is going to approximate your actual curve is going to be second degree polynomial. If you talk about the second degree polynomial, by default it's going to be a parabola. It could be upper facing, it could be lower facing. And one of the best thing, what it is, whenever you are using Simpson's 1/3 rule, you had to break the complete span of x, or you had to break the complete range of x into the even numbers. You can see yourself. Even if you have taken one step, you have started from x0 and you have jumped straight away to the x1, still you have to take 1 point in between. That means how many effective number of ways it has got splitted? The two effective number of intervals. So whenever we use the Simpson's 1/3 rule, first I used to approximate the actual curve with the second degree of polynomial. That is the first thing, which is a type of parabola. Yes. Now, the number of intervals while solving the problem should always be even in nature. Why? The explanation is there in front of you. And now if you'll see the table, the way it has been created, my dear friends, if you start from 2 to 2.1, 2.5, obviously it has been a one step. If you start from 2.5 goes to 3, obviously it's going to be second step. 3 to 3.5, it's going to be third step. And from 3.5 to the 4, it's going to be the fourth step. Even the data which has been arranged in a form of table also follows the same requirement which has to be satisfied at any case once you want to calculate the area under the curve using the Simpson's 1/3 rule. Could you understand what I am saying? So let me go down. So straight away the formula what we use, let me explain over here. Although I am not going into the derivation part of Simpson's 1/3 rule, but the same like which we done it for the trapezium rule, even we can derive this formula also. Anyways, I do not have that much time in today's class. In future, if the time permits, definitely we will go to its derivation part. And yes, it is a very, very beautiful process. See, so here it has become h divided by 3. How many number of data you will be having? Obviously, the number of interval has been 4. So you will start from y0 and you will land up to y4. Same like as we have done it earlier, the first and last data would come at very beginning. The 4 would get multiplied with all of the odd number of data, which obviously be y1 and y3. And similarly, 2 would get multiplied with all of the even data, excluding first and last data, because that has already been taken at very beginning. So here it's becoming h divided by 3. May I know what is h? H is nothing but the step size In few of the books, it's also called interval size. Interval size. So you yourself would be able to understand at very beginning the worth of abscissa was 2, then straight away it jumped to the 2.5, then it moved to the 3. That means in each and individual steps you are moving forward by x is equals to 0.5. So the value of x h has been known to be 0.5. That's fine. The value of y naught is known to me. That's the first data of the ordinate, last data of the ordinate, second and second last data of the ordinate, the middlemost data of the ordinate. Once we'll add them together, the best most answer which we are getting for this problem is going to be 20.67. 20.67. Could you understand what I am saying? The best most answer which we got, it's going to be 20.67. It was the simplest form of the problem. If you know the formula, by default, even the class 10th student would be able to solve this problem comfortably. But yes, you had to remember this formula. You had to remember this formula. And this problem has been the problem in the part of probably civil engineering. Civil engineering. Let me move forward, taking the next question. That question is coming from page number 23. Let me go into the page number 23. Yes. Here goes the next question. Here goes the next question. Anyways, two problem is already been taken based on the concept of the trapezoidal rule of integral, and again this problem has been belonging from the same category, and where we need to find the area under the curve using the trapezium numerical method. Trapezium numerical method. See what the problem states. Numerically integrate f of x, which has been 10 of x minus of 20x square, from lower limit a is equals to 0 to upper limit b is equals to 0.5. Using the trapezium rule with 5 equal division, the value in units rounded off to 2 decimal places obtained is. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? Anyways, let me do one thing. Let me calculate this integration analytically. That means we are going to take the integration of 10 of x minus of 20 of x square dx from lower limit 0 to the upper limit 0.5. I would like to explain few of the very important conclusion. Once we'll integrate 10 of x, the integration of x is going to be x square divided by 2. The 2 is getting smashed with the 10. So the factor which should be left out is simply going to be of 5 of x square. 5 of x square. Similarly, the same concept goes with this factor. Here it becomes minus of 20. Once you'll integrate, it would become x cube, and at denominator it would be just 3. It would be just 3. Yes, just 3. And now we had to take, or we had to feed their limits. The lower limit would be stayed at 0 and the upper limit would go till 0.5. See, anyways, once we'll start feeding the x is equals to 0, definitely this and this goes out. This and this goes out. And even just to simplify this problem, what I can do, we can take x square outside as a common. So the factor which has been left in is simply going to be 5 minus of 20 divided by of 3 into of x. Simply I have to feed x is equals to 0.5. So here it becomes 0.5 to the power of 2, which is equals to 0.25. Yes. Here it becomes 20 into 0.5, that is 20 into 1 by 2, that would be simply 10 divided by of 3. 10 divided by of 3. So the result what we are getting is going to be 0.2. Here it becomes 5 3, that is a 15, 15 minus of 10. 15 minus of 10, that is nothing but 5 divided by of 3. How much answer we are getting? Just try to get the answer of it. So the answer what we are getting, is going to be 0.25 into of 5 divided by of 3. Yes, tell me, what would be the best most answer? How much answer we are getting for this? 0.41. The study material says the answer has been 0.41. Similarly, if the Simpson's 1/3 rule has been used, the precise answer what we get is going to be 0.4. Sorry, trapezium rule. May I know how we will be using the trapezium rule? See, the number of interval has been clearly given. That has been 5 number of interval. So you would be starting with the x0 and you will be going till x5. Similarly, in reference to the x naught, you will be calculating the value of its ordinate, which would be y naught, y1, y2, y3, y4, y5. How many number of steps you will be having? 5 number of steps you will be having. So till this point, probably each and everything must be clear to all of us. And now the formula which we have been deriving so far, probably now you would be able to recall what used to be the formula. Towards the outermost side, you will be having h divided by f2, where the h would be the step size. And towards the bracket, you would be having the first as well as the last data. First and the last data of the abscissa or the ordinate, which is 0 and 0, which is 0 and 0, obviously 0 and 0. And there would be 2 times of the remaining data which has been left out, excluding 0 and 0, which has been at the first as well as the last side. It would be 0.8, 1.2, 1.2, 0.8. Such a easiest problem it is. Such a easiest problem it is. Yes? Yes, no? Tell me, now one more important thing I wanted to ask from each one of you. After the calculation, whatever the result you will be getting now, would be under-calculated or would be overestimated or over-calculated? Would be underestimated or would be overestimated? See, using the analytic method, the area under the curve was found to be 0.41, whereas using the trapezium rule, the area was found to be 0.4. May I know when this takes place? This takes place, I'll repeat, when it takes place, this takes place when the curve is lower facing. The curve is lower facing. What I am saying, the curve is lower facing. Curve is lower facing. And if the curve is lower facing now, you yourself would be able to understand. If you'll calculate the area under the curve using the trapezium rule, you will get to know the trapezium is going to occupy the lesser area in compare with the actual area. Actual area. So probably till this point, each and everything must be clear to all of us. Anyways, let me draw how the 10 of x minus of 20x square looks like. Just a minute. So it would give a better understanding to all of us. 10x minus of 20x square. Let me go back. 10x minus of 20x square. 10x minus of 20x square. 10x. Just a minute. 10x minus of 20x square. So here goes just a minute, it is not getting connected. See, let me draw this. Why it's not getting connected? FF has joined the session. Yes, let me draw the curve. 10 of x minus of 20x square. Let me change it to the reverse mode. 10 of x minus of 20 x to the power of 2. X to the power of 2. See. In between 0 to 0.5, probably you must be able to visualize, no? You must be able to see. This has been the worth of x as 0 and this has been the worth of x is equals to 0.5. Could you understand what I am saying? X is equals to 0 and x is equals to 0.5. And it has been a lower facing parabola. You yourself would be able to understand. It has been a lower facing parabola. Just a minute. It has been a lower facing parabola. And as I was saying earlier, whenever you are calculating the area using the trapezium method, and if you have a lower facing parabola, obviously the the reference 2 points which you will be taking now, how you will be taking over here, my dear friends, you may take the 5 number of intervals From x is equals to 0, x is equals to 0 to 0.1, then 0.1 to 0.2, then 0.2 to 0.3, 0.3 to 0.4, 0.4 to 0.5. See how the area is being calculated. How the area is being calculated. Tell me whether it has been overestimated or whether it has been underestimated. Obviously, whenever you have been dealing with the lower facing parabola, lower facing concave, with the help of trapezium method, it would be under calculated. If it would have been upper facing, then it would have been over calculated, overestimated. You can see by yourself. If you take the reference at x0, x1, x2, x3, x4, and once you will start marking the parabola, so the calculation which you have been making with the help of trapezium has been overestimated. Could you exactly understand what I am saying? So just keep one thing in your mind. Whenever you have been applying the method of trapezium over the lower facing concave, always the area would be underestimated, and whenever you are applying the method of trapezium for the calculation of upper facing concave, it would be overestimated. So till this point, probably each and everything must be clear to all of us. Just a minute. Yes. And I would like to ask from each one of you, rather giving the problem, rather solving the problem with the help of trapezium method, if I would have used the method of Simpson's 1/3 rule, what would have been the answer? The answer would have been precisely 0.41. Now the next thing comes in a mind, sir, why so? My dear friends, it has been a perfect parabola, or it has been a perfect polynomial of the second degree in nature. Yes, and we use the second degree of polynomial for the approximation of the f of x in the given interval while using Simpson's 1/3 rule. So I would say this could have been better problem. Rather given the problem in terms of trapezium rule or trapezoidal rule, they could have made this problem taking the reference of what? Simpson's 1/3 rule. In case of Simpson's 1/3 rule, the answer would have been the same, which we will be getting after the analytic analysis. So I would request to each one of you, the students should go sit properly and try to smash this problem using the Simpson's 1/3 rule and try to get the same answer. Yes, the answer would be 0.41, which we have calculated using the analytic method. So probably till this point, each and everything must be clear to all of us. We would be meeting at the same time, which used to be 9 p.m. tomorrow, with the next session of the engineering mathematics. Till then, bye-bye, take care, and most importantly, put the best effort. Thank you, bye-bye very much.